All right, so we're talking about rational function properties, and you guys are going to be able to analyze rational function. Analyze rational functions. I do have some sheets for you. We'll fill them in first, and then you guys will put them in. They are 2 pages. It is 2 pages. That's what's covering. All right, talking about rational functions. A rational function is the quotient of two polynomial functions, a of x and b of x, where b is a non-zero. Okay, first off, quotient. What's another word for quotient? Say again. Divide two things. Yes. The result you get after you divide two things. And in this case, we're dividing two polynomial functions, a of x and b of x. B is a non-zero. So rational functions are made up of f of x equals a of x over b of x. B cannot equal 0 clearly because what? If 0 is the denominator, what would happen? And what would be happening? It would be undefined, but what would be happening? Infinite discontinuity. Very good. Now the domain of a rational function is a set of all real numbers excluding those values for which b of x equals 0. So in other words, clearly we can't have 0 in the denominator, so whatever makes the denominator 0, the domain is everything but those numbers. This should be familiar. We've talked about domain, we talked about we actually dealt with rational functions at different point in times already in this year. Okay? So, reciprocal function. Y'all remember that parent function? Right? Okay, that is the simplest rational function you have. 1 over x. 1 would represent that a of x, because even 1 is a polynomial function, and then b of x would be the x part, okay? X is the most simplest one. Remember, it looked like this? Yeah? The most basic one. Now, each rational function has asymptotes, lines that the graph approaches. Okay, they can have one of these 3 types, or it could have more than one. It can have a vertical asymptote, a horizontal asymptote, but it could also have a slant or an oblique asymptote. Okay, so we all know vertical, straight up and down, and we know horizontal, left and right. But oblique could be, and slant could be a line. It could even be a parabola. It could be a lot of different things. Okay, we are actually going to go a little bit deeper into those types. Yes, and we are going to graph them. You better believe it. Yes. Next part, finding vertical asymptotes. Clearly, you do that by doing what? How do you find a vertical asymptote? Wait a minute. Wait. Someone said something first. Let's think. Female voice. How do we find it?
You said the denominator equal to 0.
You surely do. Okay, you surely do. You set the denominator equal to 0. Vertical asymptotes occur when b of x equals 0. Okay? And so we have this particular rational function, x over x squared plus x minus 2. Yes, you have to fill in that function. Okay? I prevented you guys from going ahead of me. All right? So we need to take the denominator and set it equal to 0. We got to find these values where the denominator is going to equal to 0. Now this is nothing but a good old, what type of function? Quadratic. How do you solve quadratics? There are 3 ways. Good looping time. Completing the square. Quadratic formula. And factoring. Factoring is probably the easiest one. Can we factor this? X minus 1, x minus 1? Hold on, we're looking for 2 numbers that multiply to give us
X plus 2 and x minus 2.
negative 2 and add to give us a positive 1. That's how we figure out from there. Then we set both factors equal to 0. And our vertical asymptotes are the equations x equals negative 2 and x equals 1. Vertical asymptotes are equations that are in the form of x equals something, some number. Okay? Vertical asymptotes are that way. And they are equations, so do not forget the x equals. They are equations.
Don has two vertical isotopes.
Huh?
Don has two isotopes.
This one has two vertical isotopes. Now the domain of a rational function, again, is all real numbers except where b of x equals 0. So if I asked you to find the domain of this, you all would tell me what? Raise hand. What would be the domain here? Like, no, not quite. It's everywhere except where b of x equals 0. So we already know that the denominator equals 0 and -2 and +1.
So,
Not 0 to infinity. Caleb?
Negative infinity, comma 0, parentheses.
Not quite. Brianna?
Negative infinity to negative 2.
-2.
Oh, yeah.
+1.
And then
+1 to infinity is everything but where the denominator equals 0. So not negative infinity to infinity, but negative infinity to -2. Because we got a break there. We got an asymptote there. Then everything in between -2 and 1. And everything after 1. Okay? That's interval notation. Does anybody remember how to do these in set? Raise hand.
X such that x cannot equal -2 and x cannot equal 1. X is the element of all real numbers.
Exactly.
Bracket.
Yes. Okay. We did this back in the very beginning when we were talking about domains and ranges. Actually, not just domains, outbreak. Questions on this? It's going to be very rare. Actually, rational functions will never just be negative infinity to positive infinity. There's going to be something. Okay? There's either going to be an asymptote, there's going to be another type of discontinuity, there's going to be something that's going to break up that domain. Okay? Now, horizontal asymptotes. This can get tricky. Alright? You got to look at the degree of the a of x and b of x. So the numerator and the denominator. Degree means what? What's another word for degree? Exponent. So you got to look at the exponent, and more specifically the not just any old exponent.
The highest power.
The highest power. You got to look at the highest power. If the numerator's highest degree is less than the denominator's highest degree, then your horizontal asymptote is y equals 0. Every time, Ms. Anderson? Every time. Yes. If numerator is less than the denominator. However, if the numerator and the denominator's degrees are equal, then the horizontal asymptote is y equals c, and c is the ratio of the leading coefficients of the numerator and denominator. Let's look at this one a little bit more in detail. Say I gave you the rational function 3x plus 1 over 2x minus 3. Okay? What's the degree of the numerator? A little louder with confidence.
1.
It's 1. Okay? It's 1. What's the degree of the denominator? 1. So because they're equal, your horizontal asymptote is going to be y equals c. Again, c is the ratio of the leading coefficients of the numerator and denominator. What's the leading coefficient of the numerator? What number? I forgot what leading coefficient was? It's 3. It's the number that's attached to your largest degree. What's the leading coefficient of the denominator? 2. So this right here, y equals 3 over 2 would be your horizontal asymptote. So there will be a dotted line horizontally at y equals 3 over 2, if you were to look at the graph. That's how you find it. So you look at the degrees. If they're equal, you look at the coefficients, and that's your answer. Y equals that number. Question on that? If there are, you can ask. Don't be shy. And then lastly, if the numerator is greater than the denominator, this is when you say, no horizontal, but it's slant oblique. To find these slants and oblique asymptotes, you're going to have to do synthetic division.
Yeah.
Okay? You're going to have to do synthetic division. Which means whatever's in your denominator, you have to divide it by your numerator. Okay? And we'll see an example like that on the next page. Okay? Any questions on how to find it? Like what to look for to find it? Okay, let's do this. It's fine. Okay, not a trick question. So we're going to find the horizontal asymptote of the first one, g of x equals 6 over x plus 3. Remember, horizontal asymptotes means you got to look at the degree of the top and the bottom. And then you got to figure out from there. So Tanner, what's the degree of the numerator for a? It is 0. There's nothing there. So there's basically an imaginary x to the 0 power. The degree is 0. Okay, Luke, what's the degree of the denominator? 1. So in this case, our numerator is going to be less than, greater than, or equal to our denominator, Caleb. It's going to be less than. And if it's less than, then we know that our horizontal asymptote is what, Michaela? Y equals 0. Exactly. So we look at the degree of the numerator, degree of the denominator, and we figure it out from there, okay? Let's look down at B. Monica, what's the degree of the numerator? 1. And Anna, what's the degree of the denominator? 1. So because the numerator is equal to the denominator, that was easy when I gave nobody that one. Christian, what is our horizontal asymptote since they're equal? Very good. Okay, because remember, this one you have to look at the leading coefficients. It is 15 over 1. 15 over 1 is nothing but 15. And the last one, Aiden, what's the degree of the denominator? Did I say denominator? I said denominator, didn't I? The denominator is 1. My bad. And then the degree of the numerator is what, Brianna? It is 2. In this case, the numerator is what the denominator, Donnie? It is greater. Yes, I did give you one of each type so you can, okay? So that means we're going to have to do what to find the asymptote? Synthetic division, okay? The denominator is x minus 3. So the denominator is what goes in the backwards L. What number is going in the backwards L? Positive 3. And then what goes beside the positive L? Positive 1, negative 7, and positive 10. The coefficients of the top, it always works out that way. Okay? The denominator is the divisor. It's what you divide stuff into. Bring down the 1. 1 times 3 is 3. Negative 7 plus 3 is negative 4. And honestly, this last number represents our what? Represents our remainder. We don't need that. Okay? So really and truly, I mean, we can finish this off, figure out that our remainder is negative 2, but we're not really concerned about that. This is the part we're concerned about. That is the equation of the slant asymptote. Say it again. What does equation be? I think I'm not hearing you quite right now. Y equals 1x minus 4. I think I was hearing you. Air. Blocking everything. And the reason why it's an x is because we started out with an x squared. And remember, every time you divide, you lose a degree. So that's how we ended up with a 1x. Questions on finding your horizontal asymptotes. It does not matter whether or not you have a remainder. Okay? We're only concerned about that part before. Because it's going to be an equation like a line or quadratic that we're going to graph when we actually need to graph this. Okay? Any questions so far? Kind of moving. Make sure y'all trying to stand up. Yep. The basics. Back to the basics. Finding x and y intercepts. That should be nothing new, right? To find x-intercepts, you set a of x equal to 0. What did a of x represent again? The numerator. Okay? And then to find the y-intercepts, you plug in 0 for x. Okay? 0 for x. So we're going to find the x and y intercept. I'm going to do one with you, and then you'll do the other one on your own, okay? Now, normally to find an x-intercept, you set y equal to 0. Well, realize that when you set y equal to 0 of any rational function, your first step is to multiply by the denominator. Well, 0 times anything is always 0, so you're just left with the numerator anyway, just to save you some time. So to find my x-intercept, we'll set 2 equal to 0. What is that? 2 equal to 0. That's, it's undefined, not in the sense of like an asymptote undefined, but is there an x-intercept? No. There's no x-intercept. You can't have a number equal to 0. When that happens, that means there's no x-intercept. But my y-intercept, to find that, I just plug in 0 for every x I see. So that'd be 2 over 0 plus 0 minus 3, which is what? But x-intercepts, just like y-intercepts, are written as points. What point is that? 0, -2 over 3. Okay? All x-intercepts, all y-intercepts are written as points, and it probably would be in your best interest to write them as points, because when you get to graphing, you're going to need like to plot these things. Okay? So I want you guys to do B. Find my x and y intercepts. When you get done, I want you to compare with your neighbor, and then we'll look at it as a group. All right, so we got to find our x-intercept. Alexis, what do I do? X equal to 0? I'm confused. The numerator equal to 0. Okay. Well, hey, I'm done, aren't I? Cool. What's my x-intercept? 0, 0, yes. And you guys, quick thing. Not cheating, but if the x-intercept 0, 0, then you automatically know what?
The other one is
Y.
0.
Y-intercept is 0, 0, because that's right there at the origin. Okay? 0, 0. If you plug in 0, you'll get 0 over 0 plus 0 minus 2. 0 over -2 is always 0. Places we'll find the x and y intercepts. Okay. The last thing. Okay? When the numerator and denominator have a common factor, or have common factors, then the graph of the function has a removable discontinuity called a hole. You guys remember this back from the beginning of Unit 3 when we talked about continuity of different types? There was infinite, which represented your vertical asymptotes. There was removable, that represented your holes, and there was one more called your what? Called your jump. Those were only with piecewise functions, okay? So with rational functions, you're going to see vertical asymptotes and you can see holes. You won't always have a hole, but you always want to check first to make sure that there isn't one. So to find the hole, if there is one, you need to factor the top and the bottom, if they can be factored. The top part. I'm looking for two numbers that multiply to give me 24, that add to give me 10. Don't shout out. I'm going to ask the students. There's only 2 students I haven't called on yet today. Actually 3.
Today? You call everybody else?
Yeah. Aaliyah. What 2 numbers multiply to give me 24 that add to give me 10? 6 and 4. Both positive? Yeah. All right. And Shay, the bottom. What 2 numbers multiply to give me a -12 that add together to give me a positive 1?
X plus 4x minus 3.
Awesome. Okay? So there we go. We factored the top and the bottom. Now, quick thing. I need you guys to write this down somewhere so that you remember. You always find the domain first before you find any holes. Okay? And the reason why I say this is because what's going to end up happening is we're going to end up canceling out factors to get kind of like a simplified rational function, and we're going to find everything else based off of that. But you always find the domain from the original function, not the simplified one. And I need you guys to remember that. So write it down somewhere where you won't miss it. If you need to get a highlighter and highlight it, do so. If you got a colored pen, box it with the colored pen and put a star beside it. So I always have students that forget that. And you at home watching this video, please do the same. You find find your domain first before you ever find your holes. So, this is what you do. As you see, you have the x plus 4 and x plus 4 in common on the top and the bottom, yes? Cancel those out. That leaves you with x plus 6 over x minus 3. This is our simplified rational function. Okay? Now to find the whole, you take that cancel out factor and set it equal to 0. Solve this. X equals what number? -4. That -4 represents the x coordinate of your whole. Your whole is a point. Okay? It's a point that's somewhere on your rational function. So you actually have to figure out the location of that whole, and this is what we're doing. So we take our canceled out factors, set it equal to 0, and find out the x coordinate is -4. How do you find the y coordinate? Plug in that value into the simplified form. Not the original. If you plug it into the original, you're going to get 0 over 0 every time. So you plug it into the simplified form. -4 plus 6 over -4 minus 3. What's -4 plus 6? 2. What's -4 minus 3? -7. And so your y coordinate is a -2 over 7. That's where it's located. And those are your properties of rational functions. All right, so we're looking at the homework. I'm going to do number 2 with you guys, okay? 2 says f of x equals 2x squared over x squared minus 1. Now, you do have to find a through g. Now realize that E oblique asymptotes is either going to be horizontal asymptotes or oblique ones. Oblique also stands for slant. So is it going to be D or E? Not both. Okay? So first thing we have to do is, of course, find our domain. To find our domain, we need to do what? Oh, now y'all quiet? Okay.
Define the domain.
Randomly pick people. First
Find
one,
the vertical asymptotes because the domain is
all numbers except for the vertical.
all those except your vertical asymptotes. So Eson, how do I find my vertical asymptotes?
You have to look at the coefficient. No, you look at the power of that.
That's horizontal asymptotes. Vertical ones. Set the denominator equal to 0. So x squared minus 1 equals 0. To solve this, you need what? You can factor. Or move over 1 and square root both sides. The one thing you have to remember about this is when you take a square root, it's what? Plus or minus. So I have 2 vertical asymptotes. So technically, I kind of answered C. At the same time, I'm trying to answer A. So there's part C. But part A is everything but those. So I'm going to write it in set x such that x does not equal -1 and does not equal +1. X is the element of what? All real numbers. There's part A. Now B says to find the holes. You won't have holes every time, but how do I figure out if I do have holes? What do I have to do to find a hole?
You gotta
Factor. Well, I already know the bottom factors because I didn't do it to my vertical, but the bottom can factor how? X plus 1, x minus 1. Can I factor the top? Nope. If I could, I would, but I can't, so I won't. So I have no holes. Nothing factors, nothing cancels out. Sorry, stuff factors, but nothing cancels out. So I have no holes. Okay? Now D says to find the horizontal asymptote. Here, though, horizontal asymptote. Here is where I do what, Michaela? How do I find my horizontal asymptotes? That's x-intercepts. Gotta look at the degree. And so Malay helped you out. I gotta look at the degree. Since they're equal, that means my horizontal asymptote is the coefficients. Because they're equal. It's the coefficients. So y equals 2. When though is it? When is it 0? When the numerator is what the denominator? Different, but in what sense? Less than the denominator. That's when it's 0. Okay. So if we have a horizontal asymptote, that means we don't have any oblique. So we skip that one. X-intercepts, yeah? X-intercepts. We find those by doing what, Anna? How do I find my x-intercepts?
You have to plug it
Oh. That, you got them backwards, and I think that's probably my fault because I thought I said x-intercepts. You gave me y-intercepts. I know because that was F and I mixed it up. So let's do it right by order. Y-intercept, which is F. How do I find my y-intercept? Plug in 0. So that's 2 times 0 squared. 0 squared minus 1. So that's going to be 0 over negative 1. So my y-intercept is what? No? 0, 0. Because that equals 0. And if this is my y-intercept, then I know automatically my x-intercept is what? Say again? 0, 0. And you can always find your x-intercept by setting your numerator equal to 0. So there's an example worked out for you. Any questions? Okay. We're going to look at number 10. Okay, we're going to look at number 10.
Whoa.
Okay. So, you have x squared minus 9 over x squared. Okay. So, you want to go ahead and find your domain. Okay. A is your domain. To find your domain is all real numbers except where the denominator equals 0. So you have to set your denominator equal to 0 and solve this out. Okay? Can you factor this? Can you factor this? Yes, you can. Okay? Now remember, you're going to factor this because this is a quadratic. That's how you solve quadratics, factoring between the square quadratic formula. What are the two numbers?
Positive 1 and
So, the domain of this function is going to be all real numbers except where x equals negative 1 and x equals 3. So x is not equal negative 1, is not equal 3, and x is the element of all real numbers. Okay? Alright, so there's A. There's the domain. Now B says to find the holes. The holes are found by factoring the top and the bottom, okay? And once you factor and find your holes, use the simplified form for everything else. So we already know the top. We already know the bottom. The bottom is x plus 1, x minus 3. What's the top factor down to be? The negative 3's cancel out, leaving you with what? What are you left with? And x plus 1. To find our whole, we take the canceled out factor. Set it equal to 0. So x equals what? 3. That's the x coordinate of your whole. How do you find the y coordinate? Plug it into the simplified version. So that's 3 plus 3 over 3 plus 1. 3 plus 3 is? 3 plus 1 is? So you can say 6 over 4 or 3 over 2. There's your whole. The black is your domain. Now you use the simplified version to find everything else because the simplified version is taking care of the whole. Okay? You've already taken care of the domain. It makes things a little bit easier. To find your vertical asymptote, you're going to set the what? Denominator, which is now x plus isotope is x equals -1. So not the other one, because the other one, the domain basically takes into account all of the points where the graph is undefined. That's vertical isotopes, that's holes. Okay, so that was my bad for saying that earlier. That's why I was like, let me do another one. Okay? So in this particular case, we didn't have two vertical isotopes. We had a hole and a vertical isotope. Okay? A hole in 3 3/2, and vertical isotope in -1. Now to find our horizontal isotope, we can still use the simplified version. We look at the degree. What's the degree at the top?
1.
1. What's the degree at the bottom? 1. Since they're equal, it's going to be the coefficients, which are 1 over 1. Okay? All right. If you have a horizontal isotope, that means you don't have a oblique, so we don't have to do E. Now to find F. F is your y-intercept. You plug into simplified form, which makes things a lot easier. Okay, no x squares, none of that. It's a lot easier. So to find our y-intercept, we plug in 0. So my y-intercept is going to be 0, 3. And to find your x-intercept, you do what? Set the top equal to 0. So my x-intercept is -3. I just wanted to do another example, and I know, yes, this does look like a lot, okay? But I wanted to do this just to make sure that you guys had examples where there was a hole, but you can use the simplified version to make everything a lot easier, okay? Say again? There was a vertical isotope. There was a horizontal isotope of y equals 1. There's no.